So we forgot a little something on our unit circle yesterday. What was it that I forgot? The coordinates. And it's just the coordinates here, right? So if you look at your unit circle that I gave you, which is this.
It says it for all of them.
Oh, well, we're gonna get to those. We're not gonna, well, maybe we'll do those today. We'll get to those. So let me come back. I'll do the coordinates after I finish the word problems. How's that? So flip it to the last page, because we're gonna have to do special right triangles for those. So we finished here yesterday. Did you plug this into your calculator?
Yes.
Okay. So what'd you get?
85 degrees, 21 minutes, and 0 seconds.
Okay. So 85.35, and then if you hit second function apps, that'll get you to angles. And then what'd you do from there? Because we're assuming that's in degrees, right? So go to, the easiest way is to go to DMS. You can follow the directions that are on there too. But don't I get the same answer?
Mm-hmm.
Yeah. And then on your homework, you had some that gave you seconds, did it not? Yeah. So 80, no?
Yeah.
It should have 85 degrees, 21 minutes, and 0, that's a seconds, right? So did you have any issue on yesterday's homework with just that specific item?
Some of them you had to like round, right? Like they didn't-
Might have,
I
like
didn't-
which one?
I didn't get, oh, I got this one.
You can't put the degree sign.
Yeah. Say the degree sign, it messes up your
Yeah.
answer.
Where are you looking in? Like which one?
All of them.
Oh, you mean as you're putting it in, you put the degree sign in, like here?
Yeah.
Yeah, I don't. Did this one say
The
to?
instructions tell you.
Oh, well, we did it on Amber's calculator yesterday, and it worked. She put hers in, and I think it worked on mine too. Do you have the newer calculator?
No, I have the older one.
Yeah, it worked on hers.
It didn't work when I did it last night.
Weird.
When I plugged
Yeah,
in
'cause-
the-
Yeah, it
when I
doesn't
plugged
work
in the
when
degrees,
I take the.
But everybody, it worked if you did DMS, right?
Yeah.
Okay, so just do it that way then. Fair enough.
Does.
Decimal, or degrees, minutes, seconds.
Yeah, but
Yeah.
I don't know where it is.
It convert, oh, well, it's under
Second.
second apps,
Second.
right? Second apps, and see, that's where your degree is, that's where your minutes is, and then number 4 is DMS. Okay? Let me see yours. Because I thought I did it on mine yesterday and it worked. Oh, well, yeah, okay.
That's if you add the.
Yeah, don't use DMS. Don't do degrees with DMS. You either have to follow it exactly as this says here, like that, or if you're gonna use DMS, don't put degrees in.
That's what it says to do for something like that.
On here, but this one isn't telling you to do, it's telling you to do 1 and then 2. This one isn't telling you to do DMS.
No, about the second one.
The example six,
Example
B tells
6,
you to do
it
that.
says.
Oh, down here?
Yeah, it says.
Oh, okay. Okay, gotcha. Yeah, then cross that out and just put DMS. All right, so then let's,
Do I need a calculator to do that though?
yeah. We'll look at the ones on your homework. Well, okay, technically no, but who wants to do it the long way?
Well, like, my calculator doesn't really work with that, so.
Yes, it does. I'll just show you how to use it later. So those are your answers to those. I mean, this one's more of a pain. This one you could have done without. This one you could have done without. You know, but some of them are more of a pain. All right, so then let's look at these word problems because they're a bit tricky. So let's concentrate on this one. There we go. All right, so the arc length of theta, and theta is your degree measure, is equal to S, which is your arc length. So they said here that S is your arc length. So S divided by R, what do you think R is? Radius. So here we don't know our arc length, but we know our radius is 40, and we know that our degree is 40 degrees. The one thing that you need to realize that's not written here is in order to use that 40 degrees with this formula, that you have to convert. So must convert to radians first. So that's a definite must. So we're going to have to convert the 40 degrees to radians first, and then we can put that into the formula. So step 1, let's do the conversion. How do we convert 40 degrees to radians? What do I multiply by? Yeah, pi over 180. If I want radians, pi goes up top, 180 is on the bottom. And so my zeros cancel. And then 4 and 18 are both divisible by 2. And so I actually get 2 pi over 9. And that's in rads. Bless you.
Can you simplify that more?
No.
Because one is a fraction.
Don't change it into a decimal. Leave it as a fraction. Okay? So then I'm going to move out just a little bit. So then part 2, now we can plug it into the formula. So I'm going to replace theta with 2 pi over 9 equals, I don't know s, so it remains s, over my radius is 5, right? How do you solve for s? You've got a fraction equaling a fraction. Cross multiply. So I've got 9s is equal to 10 pi. You all right with that? Right? And then divide by 9. And so your final answer is s, your arc length, is equal to 10 pi over 9. So there's your answer. Questions about that? The key is to do that conversion of 40 degrees first. And all we're doing is using the formula that they gave us. I cross multiplied. So we did 9 times s and 2 pi times 5, right? Because it's your proportion, or yeah, proportion. Does that make sense? Okay. So then look at example 8. So Earth has a radius of 6,378 kilometers, and so you see that here. Find the latitude theta, that's your angle, in degrees between cities. So this is one city. This is another city. Because they'd be on the surface of the Earth, wouldn't they? Mm-hmm. Okay. And one which is 4,000 kilometers directly north of the other. So haven't they actually given us s? So this time we know s, we don't know theta. So step 1, plug in what you know. So I've got theta is equal to, my s is 4,000 kilometers divided by, my radius is 6,378 kilometers. So my kilometers are going to actually cancel. I put them in there for a reason so you could see why it cancels. You're not writing any of this down?
No.
I would if I were you. And then take your calculator, and if you don't know how to use the fraction button on your calculator, it's really a handy thing. So take 4,000, which you can't see that because of the glare. Oh, it's not even on. So take 4,000 and divide it by 6,378. So obviously that's a decimal. How do you convert to its fraction, reduced fraction form?
1.
What?
That's 1.
Yep, go to your math button. And I want fraction. So hit 1 or enter. And then hit enter again, and that'll give you your reduce. This one wasn't so hard to reduce, was it? So theta equals 2,000 over 3189. Is that in degrees or radians? Yep, so that's in radians. And so we have to convert back to degrees. Because theta will always be in radians right now, according to this formula. right, so then part 2, how are we going to convert? If it's currently in radians, 2,000. Oh, I'm losing juice in there. I have to switch to another color, sorry. So 2,000 over 3189, what's our conversion? It's currently in rads, 180 over pi. And so we're going to actually get our decimal equivalency for this. So go ahead and plug it into your calculator. So 2,000 divided by 3189 equals times 180 and then divided by pi. And you have to use your pi symbol, don't use 3.14, and then round to 2 decimal places. What do you get? 35.93, and that's in degrees. Okay, so there's that. Then let's go back and look at our unit circle. Okay, so let's look at this. We're going to assume we have to fill in the degree and radians. So we did degrees yesterday, right? Okay, well, we did. You missed it. And I had my original. Well, we'll have to go with the flow. So what happens when I have so many things? Okay, so we're going to start with our first quadrant. Anybody remember what the radius of your unit circle is from last year? Really? Your radius is equal to 1. It's assumed that your radius is 1. Maybe I'll use green. It'll show up better. All right, so that means that over here, this point right here at 0 and 2 pi, this point is 1, 0. So what's this point up here? 0, 1. What's this point over here? Negative 1, 0. And so then what's this point way down here? 0, negative 1. So those are easy, right? All right, so then we have to figure out this right here. So this had a degree measure of what? 30 degrees. Okay. And then we came up with the radians yesterday also, right? Which was what? Pi over 6. Okay. This was what degree? 45. And what was its radian measure? Pi over 4. And this was what degree? 60. And its radian measure? Pi over 3. And then this was 0 degrees, right? And then how many in radians, what would that be? It would still be 0. And then 360 degrees would be 2 pi. And then up here, we're just going to finish off the first quadrant. Up here, what was the degrees? 90. And then the radian measure? Pi over 2. So let me just show you a pattern that you can see on here. So notice that the pattern starts here at 2, and it goes 2, 3, 4, skips 5, and hits 6. So that's something that might be handy for you to see. Okay? Then, let's just look. We're going to extend this out all the way until we get up to here. Okay? So here's a right triangle, isn't it? What's this degree measure here again? From here to here, this is 30 degrees, right? So if this has, remember your special right triangles? I'm going to go up here. I'm going to make your special right triangle look like this. So if this is 30 degrees, what was this up here? 60 degrees. And then in geometry, we called this side rad 3, and this was 2 side, right, or x. So some of you did x, you did x rad 3, and you did 2. Because our unit circle has a radius of 1. So across from your 30-degree side is 1. Across from your 60-degree side is radical 3. And across from your hypotenuse was 2. Okay? Your other special right triangle was a 45-45, wasn't it? And doesn't that include all of our angles that we're talking about here? And then in geometry, you had side, side, side rad 2, right? But last year, what did you have? If our radius is 1, what'd you have? 1, 1, rad 2. So we have to come up with our ordered pairs. So remember that to get 30 degrees, so if this is 30 degrees, we want to look at sine and cosine. Take your calculator, and we're just going to look, before I even get to the 30 degrees, just look at 1, 0. I want you to put into your calculator and make sure that you go to your mode and make sure that you have it in degrees. Because it's probably in radians. So change your mode, make sure it says degrees. Oops. Then quit out of that, and I want you to find the sine of 1. So hit sine, and I want you to put in 1. What do you get? Okay. What's the sine of 0? Interesting, right? So the sine of 0 is 0 degrees, right? Okay, find sine of 30. Huh, what'd you get? Sine of 30 is 1/2. So look over here, and 30 degrees, how do you get 1/2 off of 30 degrees? Side, there's 1/2, right? 1 and 2. So 1 is side what? Let's go back to your trig. Opposite over hypotenuse. So remember, your sine is side opposite over hypotenuse. Yeah, and yes.
Wait, what did you do before?
On what?
On mode?
Oh, go to mode and make sure that degrees is lit up. Okay. So then cosine is what? Adjacent over hypotenuse. Okay.
Is this the second
Yes, SOHCAHTOA, and we're going to go more into it in detail. All right, so then for 30 degrees, oh, that's the security. I'm like, what the heck was that? So then I want you to also put in here sine of 1. Oh, no, wait, cosine is 0 degrees. Sorry, cosine is 0 degrees. All right, so I have up here sine of 0 degrees is 0 and cosine of 0 degrees is 1. Isn't this line right here 0 degrees? And didn't this represent, so when I found the sine of 0 degrees, what did I get? 0. So sine is here, and then the cosine of 0 degrees was 1. So this is your cosine. Your sine and your cosine are going to give you your ordered pairs of x and y. Yes. Because you probably don't have it in the right measures. Mode, yep, you didn't set your mode to degrees.
Oh, I thought I did.
Nope, it hit enter. So if you didn't get these, then your mode is not in degrees. Okay, so the whole point of this is I want you to also write up here a note to self that in your ordered pair, you've got cosine, it goes alphabetical and then sine. So that's why we're looking at all of these. So you don't have to memorize any of them. You can use your special right triangle. So go back to your 30 degrees. If we're finding cosine first, what's your cosine? Yep, adjacent over hypotenuse. So rad 3 over 2. So I'm going to put this as rad 3 over 2. What's your sine? 1 over 2. So 1 over 2. Then what degree is this one? 45, right? So go to your 45-degree angle. What's sine? Actually, sorry, what's cosine? 1 over rad 2. And technically, 1 over radical 2 is not in proper form, is it? Don't we have to rationalize that? So how do you rationalize it? Rad 2 over rad 2. What do you get? Rad 2 over 2. So that's technically what should go here. Sometimes you're going to see some textbooks putting it as 1 over rad 2. I want you writing rad 2 over 2. It helps with the pattern if you write it this way. All right, so then isn't sine and cosine on 45 degrees exactly the same? So isn't the sine also going to be rad 2 over 2? So what's nice about pi over 4 or 45 degrees, both sine and cosine are the same. So then this one's 60 degrees now, right? From here to here is 60. So we're going to use our 60-degree special right triangle, and we're going to find cosine. So remember, cosine is adjacent over hypotenuse. So what's adjacent? 1, and the hypotenuse is 2. Isn't that just the reverse of your 30 degrees? Yep. So what do you think sine is going to be? Rad 3 over 2. And so put in 90 degrees for cosine. So do cosine of 90 degrees. Guess what you're going to get? What should you get? 0. What did we get? So put in sine of 90 degrees. What do you anticipate? 1. And there you go. So have I memorized any of this? No. But all you have to do is look at the pattern. So look at the numbers. We start with 0, right? And then look at what's going up top. There's an inside track here, and then there's an outside track here. So all of your denominators are 2, aren't they? So look at your numerators. I've got 0, then 1, 2, 3, 1, right? 0, 1, 2, 3. The square root of 1 is 1. That's why there's no square root above it. Then 2, then 3. So you hit 1. Then go back to 0, 1, 2, 3. Doesn't it just go in reverse? So if you want to, you can remember it that way. If you don't want to do any memorization, put your special right triangles up here, and that's what I'm going to do constantly, and write it that way. Then all you're going to have to do is reflect. So we're going to do all the reflections in the next lesson, but I just wanted to show you that much of it. And then that's going to start to get you these ordered pairs. So on Tuesday, we'll look at the rest of the ordered pairs, because that's enough to fill up your brain right now, is it not? But none of that's new to you, is it? Didn't you have that last year? You didn't have these ordered pairs last year at all?
No.
Oh, well then that's new to you. But does that make sense how we came up with them? Okay, I want you to ponder it, sit on it for a while, and we'll talk about it more on Tuesday.